Hey everyone, my name is Megan. I'm here at the Bahamas doing research with Dr. Langerhans, and right now I'm at one of our lovely blue holes, which, as you know, is a naturally occurring water-filled cave. And what we found in these blue holes are some amazing creatures, including the mosquito fish. Mosquito fish is represented right here, have a couple right now, and something we've noticed about these mosquito fish is depending on which blue hole it's in, it'll have a different size caudal. And the caudal is right there in orange. Some are larger, some are smaller. Another really cool creature that we found in these blue holes are called piscivorous fish. Piscivorous fish are basically fish that eat other fish. So of course they're going to be predators for our lovely mosquito fish. So one way that the mosquito fish escape these predators is through a strategy called fast start escape. So virtually the mosquito fish are swimming along, they see a threat, and they jerk away. So it's this rapid burst of high energy to escape these threats. So Dr. Langerhans and I have, through this research, come up with a hypothesis. And the hypothesis is that the larger caudals on the mosquito fish actually enhance the fast start escape strategy. So in order to test this hypothesis, we've come up with three predictions. Our first prediction is that the mosquito fish with the piscivorous fish in that same environment have a greater fast start escapes mechanism and thus a greater survival versus the ones without the predators in their blue holes. The second prediction is that the body shape actually affects a greater fast start escape as well, and thus also a greater survival when blue holes with predators. And the way we measure this is actually through a method called MPF. So the M part of it is the morphology, which is just essentially the size and shape of the mosquito fish. Then we move on to the P, performance, which involves the fast start mechanism. And lastly, fitness, which is the survival success with the predators. So our third prediction is simply that the body shape divergence between the mosquito fish, the difference there is also on a genetic level. Okay, so let's hear about our results. The first prediction we showed, the fast start escape was actually 42% higher, and the survivorship was 50% higher in the blue holes with the predator. Really great. For our second prediction results, we see that the larger caudals have a greater rotation and acceleration, and you can see that here with these strings. So the larger one, once it jerks away, you can see how that string moves pretty quickly and it rotates, right? Whereas with the smaller caudal fish, it doesn't do as much rotation when it jerks away. So we found this correlation, and this was with the MP part of our method. And to test for the PF, we found our results that correlated the better rotation and acceleration in the larger caudal fish to also have a higher survival. Lastly, for our third prediction, we found that 80% were correctly matched in body shape with the wild mosquito fish. So all these correlations are great, but we have to remember that it doesn't necessarily prove causation. Another point to make is that there's a trade-off with these larger caudals. So although they seem great in environments in the blue holes with the predators, the mosquito fish with the smaller caudals in the blue holes without predators actually enhance their endurance for other things like feeding and mating. So we see this natural selection, which is a major force with predation. So this predation is this major force of natural selection for a phenotypic change in the mosquito fish. So for a physical change for a larger, smaller caudal in the mosquito fish. So this is a great example of a phenotypic speciation of an entire species here on our Great Bahamas. Hope you enjoyed and you learned something. Thanks for watching.